Hello guys and welcome back. Before we move on, let's take a look at the basic idea of the networking of Unreal Engine. If you have time, I highly recommend you to read through all these. This is going to have more detail than what I can offer. Uh, they have covered every detail about networking. The things I do recommend reading is all those things like replication for actors and variables. You can think of replication as networking. They're just the same thing, different words. Um, right. But let's talk about the basic idea here, right? So uh, this graph basically says how the structure works. So you'll have a server somewhere, right, set it up for all the players, and then there'll be a bunch of different players playing the same game, right? And what's happening is that when the server, or when those different local players logged into the game, they'll communicate to the server. The server will make them log in, do some checking, of course, first, then allow them to log in, right? And then they will all be appeared in the server, right? The server will create their player pawn and their player controller, right, on the server to represent them. Okay, so at that moment, all the clients are connected, and then everyone is running the same instance, right? Of course, the server will tell other client when one client logged in, the server will tell the other clients, okay, there's a new client logged in, create their pawn also on the local machine, right? So at that instance, the world, the game, the instance of the game on the server is the same on every client, or I should say on every client, the instance of the game is going to be the same as the server. Now, when the game starts to progress, some player will hit buttons, like for example, attack button, right? And when maybe this one hit the attack button, a attack request will be sending to the server, right? The server will receive that request, do some checking for things like, can you attack? Are you dead or something like that, right? Checking those things. And then if everything goes okay, the server will perform the attack on the server, right? Now, because server has everyone in there, server will just do the attack there, almost like there is a local player playing attack there, right? The server will do the attacking logic, do the damage, reducing health, but that's all happening on the server. The client doesn't know that yet. Okay, all the client does for this one is sending a request to do attack. The other client knows nothing about it. The server will do the calculation, update the health, right? When the health is updated, the server will say, okay, this health value is different for this guy, or for whatever is being attacked, right? And that information will be transferred over back to all the individual clients, right? And these clients then knows about that change, right? The health is different because of the attack. Then they will update their local machine based on that change, right? That's the gist of it. That's the basic idea, right? So the reason it's doing that is because you want the important game rules, right, the logic, to be happening on the server only, right? And that way you can prevent cheating, right? If the client is doing all the calculation and tell the server, okay, my house has changed, and then the server transfer that to all other clients, you would immediately see that the client could locally hack into that variable and change it. And that's going to update to all the other clients, which will result in cheating, right? However, if everything, including the updating of the variable, is on the server, and the only way you can cheat is actually hack into the server, right? So that way we can prevent cheating locally. All right? So that's the basic idea. The main takeaway will be, if you want to do something that's important to the game logic, that has to be happening on the server, and then the server will update it, and then it's going to transfer that information back to the client, and the client will be using that information to update their local instance of the game and try to just be the same as the server, right? In other words, server is the one true reality, and all the clients will only be sending requests to the server update the reality here, and then pass the information back to the clients, and the clients will try to use those information to update their own local instance to be the same as the server, right? So because of that, if we go back and take a look at our game, you can see, well, the server is doing its own thing, but it's not really telling the client what's going on, right? That's what's happening here. Well, on the clients, even worse, the client is doing its own thing also, right? It's trying to reduce health even on these guys, but that's also only happening locally. It's doing the important game logic locally, which is going to be, you know, something that you can really cheat, right? So of course this is not going to be ideal, right? We want this attack action to be happening on the server, and server will do that on the server locally, right? And then it's going to pass the information back. That's going to be a better solution here. So let's see how we can do that. Okay, I'm going to close that, and then back here to our code, you can see we have this attack function, right? If you go ahead and take a look at the input here, right, you can see we're doing attack over here, right, which calls our attack animation like that. Okay, so instead of doing that, we can actually make it to be a request to the server. So what I have to do is changing this function into a new function here. Okay, and I'm going to call this server, and then reliable with validation. Okay, the instance that you add this function decorator or this macro on top of the attack, right, and you adding server in the specifiers, you're telling the game or the code that this is going to be a request to be called on the server. This is also become something we call a remote procedural call, right? One thing you probably want to read more about it, RPC calls. Click on there, and I think they're gonna give you a link somewhere to, yeah, go there and read the whole thing also. A lot of those documentations need to understand each other. So if you're reading this and you're seeing a lot of things you don't understand, especially when there is a link for you to go in, you go in and read it, and then you go back out and keep on reading. If there's something you don't understand, you don't think you have enough information to understand it, keep reading until you finish this. Keep those questions as notes, and then go back and reading others, and there could be an explanation on those things somewhere else, right? Don't feel too frustrated. This is going to be difficult to read. Any complicated system is hard to document. So, all right. So remote procedural call, what this means, this is going to be meaning that this thing will be called not locally. It's going to be called somewhere else. That's what remote means, right? Remote procedural call, or basically function call, right? So we're asking the server, right, which is not locally now, it's on the server. We're asking the server to call its own attack function. Or whenever you call attack here, it's going to be calling the function on server. It's reliable, meaning that this guy will eventually reach the server, right? If you mark it as unreliable, you can do that actually, unreliable, right? That can also be a viable option. What that means is that it's not very important. Maybe you're playing a VFX or something, because of the bandwidth limitations, unreliable things can be dropped just to boost up the connection speed. Reliable means it has to be reaching there. It's important to the gameplay. With validation means that this will be validated before executing on the server, right? And we can specify what kind of validation needs to be done. Okay, now just to be more specific, I'm going to change that to s_attack, meaning that the function is for server. You can have an s in front of it. Okay, let me copy that name, and I'm going to go to the CPP file, and let me go ahead and try to implement it. Okay, so it's going to be called void a swordsman column s attack, but then you have to have a underscore and type in implementation, and then parentheses, and then that. Okay, and also you have to also create another function implementation with the same name, but this time validate. Okay, and because we're changing the name of the function, we have to change that to s_attacking here. Okay, notice that we don't really have to implement this function called s_attack. We have to implement two different functions, one with implementation, another one with validate. And this one has to be a Boolean type, return type has to be Boolean. Okay, so what's happening here is that when we call s_attack here by clicking the attack button, this will ask the server to call its own s_attack function. Okay, now before that happens, this will be called first. Okay, and in here you can do all the checks you want to do, and then if everything's okay, then you return true. That's going to be saying, I have validated everything, everything's okay, you can now proceed, right, to the actual attacking. And after that, it's going to call this function. If this returns true, right, this function will then be called. And then, you can do the actual attack logic in here. Now, if this returns false, that means something is wrong. The client is cheating or something. I think in the default settings, the system will just disconnect that client. So we're not trying to check anything here. So we're going to say return true. But this is the convention you have to follow. You have to have this function because you have the with validation. And that's something we always want to have. Okay. And then here in this implementation, that's where we actually want to have the attack happening. So let me go find that original attack function and just cut it out and then delete that function. We don't need it anymore. Now back here to the implementation of this, we can then paste this in, right? So long story short, when we ask for attack, because this is a server function now, it's going to pass to the server. It's going to eventually reach there because of reliable, right? And then before we run this implementation, we'll run this first. And if this returns true, then this will be called on the server. Okay, let me save this and then close this and then go ahead and run this again. Because I have changed that, sometimes you need to rebuild it for it to work. Oh, got a warning here. Has no member implementation. I might have a typo somewhere. So let me just have one more S in here, and then Alt-Shift-I to create that. No, maybe have some other stuff just to ask the server to do that for me. No, sorry, not the server, the auto completion to do that for me. I don't know why it's complaining about that, because the naming should be there. Let's give this one more try. Oh, a server here, some type of thing. Maybe that's the issue. Because the naming seems to be fine. Let me change back to s_attack. All right. So yeah, you have to basically implement those two functions, right? s_attack implementation and s_attack validate. Those two functions. Be aware that this is Boolean, right? And you don't have to implement the actual s_attack. Okay, just those two. And Unreal will work its magic with this Unreal header tool to make it work. Right. So now if I go ahead and play, and then let me go to the client here, and I'm going to walk in front of the server, which is this guy, left click. You can see now what's happening is that the animation now is only playing on the server. Right? It's not playing on the local client anymore, which is pretty funny, right? But that's some progress. This is something that's kind of like working on the first step, right? We're asking the server to do it. And it's not going to do that on the client yet because the server haven't tell the client what happened, haven't asked the client to do anything. But that's the first step, right? We need the things to be happening on the server, and now we're doing that. Okay, this is already 14 minutes, so we're going to stop this one now. In the next video, we're going to keep on going now tell the client what to do after the server is doing it. Okay, let's go ahead and do that in the next video.